A very warm good morning to everyone. So today we are going to discuss about the introduction to diagnostic process of ECU, or you can say the electronic control unit. In some of our previous sessions, if you will gone through it, we have discussed about the basics of working and as well as the what are the components of the involved in the electronic control unit, and how the electronic control unit is designed and developed in the process of vehicle development, and what are the process involved in the ECU. Everything we have discussed in the previous sessions, or you can say the previous videos. So in continuation of that, today we're going to discuss about the diagnostic process of the ECU. So basically diagnostic is the term which is nothing but analyzing the problem, or you can say the any what you call problems, or the malfunctions which is happening in the ECU or ECU related components. This diagnostic process will be used. So, so ultimately, that will be used to diagnose the system components, and as well as the ECU related aspects. So, why first of all the diagnostic is needed in an ECU means, first of all, the ECUs tend to operate in a very rugged or dynamic environment. It is not going to operate in a very static conditions like that. It is going to operate in a very dynamic environment, like presence of lot of vibrations, presence of fuel spray, dust and sandy conditions, corrosive liquids are also sometimes it is spraying, and water splash. So sometimes if you will see the operating temperature of the ECU will go beyond 100 or 120 degrees Celsius also, and more vibrations. If you take the engine ECUs directly, in some vehicles it's directly coupled towards the engine body itself or close to the engine, and some of these ECUs are present in the engine compartment like that. So in this case, what will happen? The more dynamic behavior and more rugged, vibrant operating conditions, it will create some kind of faults in the system, and as well as the higher electromagnetic lines, because spark plug, injector, all these components consumes more amount of, or more value of current. So thereby it can able to create some kind of faults, not occasionally or not frequently, but sometimes in occasional way. So in this case, the problem needs to be sorted out. So for that, we need a proper diagnostic system in the vehicle, or you can say there is a proper diagnostic system is needed for the ECU. So why diagnostic is needed in the ECU is that diagnostic system checks the state of automotive ECUs and their functions, whether the ECU is correctly operating or not, and all their functions has been met or not. So it will first of all identify the defective component while driving, not only during the driving, and of course during the vehicle non-driving condition also. So provides the backup values, such as maintain the safe driving. If the safe driving, there is a limpo mode, in the sense, for example, if some fault is happened, immediately it will go towards the what do you call limpo mode. Limpo mode is nothing but if the vehicle speed is not go more beyond 30 kilometer or 25 kilometer per hour, according to the manufacturer to manufacturer. So that will call as a limpo mode, or you can say the safe driving mode. So if any problem in some component is happened, so this limpo mode is started. Why this limpo mode is given means, for example, if that only because of that limpo mode, you can able to limp the vehicle or move the vehicle towards the nearest service station. So that's why the ECU will be directly moved into the limpo mode if there is any fault in the system, and prevent the subsequent damage also, and accordingly it will reduce the emissions as well. So these are the certain providing the backup values, and similarly any problem is there, the diagnostic system will report the problem to the driver by means of the malfunction indicator lamp, or you can say the mill lamp, which is present in the instrument cluster. That instrument cluster or a driver information system which is in front of the driver, which consists of a lot of color lights. So that are all some kind of a malfunction indicator lamps only. So and, for each and every fault in the ECU, any particular ECU or a group of ECU, the particular fault can be stored in the what you call ECU memory. So and similarly, the mill lamp indicator lamp indicates that there is a fault in the vehicle, and it's affect the emission or vehicle performance or vehicle operation or anything. So it is not only it will indicate the emission, of course it will also indicate the what is the fault, whether ABS CC is a fault, or the engine ECU there is a fault, in which ECU there is a fault, only it will just indicate there is a fault. So the system lamp indicates that fault has occurred in the vehicle and its activation specific to the vehicle manufacturer. So again, according to the system level ECU, the type of the faults can be varied. So what is diagnostic basically? So it is a centralized fault management system. So it is a centralized unit. In each and every ECU, there is a separate module or a segment allocated for the diagnostic system. And all those diagnostic components of the ECU will be connected towards the central fault management system. That is a central fault diagnostic system. So this is to fulfill the regular regulations of authorities like OBD onboard diagnostic, CARB or a European OBD, like that. In order to fulfill the regulations, this diagnostic will be used, and of course it will ensure the safety operation for the passengers who is going in the vehicle, and similarly avoiding the unnecessary reactions if there is any fault has happened, and also it will provide the reported state of the component in a suitable form for what you call the efficient repair, and for example which component is fault, whether the technician has to directly go to that fault. So it will tell, the diagnostic system will tell, as a service technician you have to repair this component, like that it will directly direct you. And of course, as I discussed, it will provide the lymphome mode operation if possible, according to what you call safeguard the components. If more defective components means if the further defect should not affect the operation of the vehicle or other system components. So basically, the diagnostic system check the what you call state of the art functioning of the ECU, and accordingly it will note down the errors. So those errors, if any fault is there, accordingly for each and every fault, there is a error is associated with that. There is a separate fault code will be generated. That's what we'll call as a diagnostic trouble code or DTC code. That DTC code is associated with each and every error present in the what you called occurred in the particular ECU. So that error will be in the form of code will be stored in the memory of the ECU, and from that code, either there is a two types of diagnostic can be done. One is a onboard diagnostic and another one is a offboard diagnostic. Whereas this onboard diagnostic monitors the emission related issues in the engine ECU only. OBD1 or OBD2, it is only with respect to the what we called engine ECU related aspects. Only it will monitor the emission related. For example, if the exhaust gas oxygen sensor got failed, immediately it will indicate the information to the driver, and it will try to rectify that fault, or otherwise it will immediately stop the vehicle also. It will not give the required performance also, because as a passenger we are not concerning about the what I called whether the EGO sensor is failing or whatever sensor is failing. Yeah, for us, as a passenger, sometimes they will think that for them the vehicle has to move. Whether only ultimately they will check whether the fuel efficiency is affected or not. If the fuel economy is not affected, then they will not concern about what is the kind of fault, all those things. So for that purpose only, the OBD has been inbuilt or OBD has been used. By means of this OBD system, only the emission related components or the emission related aspects will be monitored, and if there is a fault, and immediately it will restrict the vehicle operating mode. And another one is offboard diagnostic. Offboard diagnostic in the sense, when the vehicle is in off condition, or you can say that take the vehicle to the service station, and there the technicians will connect the scanning tool or the laptop with the scanner scanning software, and they will able to retrieve their trouble code, and accordingly they will able to rectify the fault. So this is what we'll call as onboard diagnostic and as well as offboard diagnostic. Onboard diagnostic is nothing but in the way during the vehicle operation, there itself it will able to diagnose the problem, and it will able to inform to the driver. And offboard diagnostic is that that not that much important or not that much important faults, or the fault which is not that much majorly affect the vehicle performance or the vehicle output, it will be retrieved or it will be serviced with the help of the offboard diagnostic capability only. Why two diagnostic systems, that is onboard and offboard, is used means, that is OBD, that is onboard diagnostic, warns the passenger by activating the mill lamp. That is we will call it as the onboard diagnostic. And whereas the offboard diagnostic stores the fault to be retrieved only in a garage, or you can say in the service station. So that is OBD is, as I said, it will be during the vehicle operation, that is state of motion. and another one is for during the state of rest operation. And onboard diagnostic with offboard diagnostic. Generally, the what you call for both the thing, you can say the malfunction indicator lamp will be glowing. In a OBD, also the according to the emission level, the malfunction indicator lamp will be glowing, or the malfunction indicator lamp will be operating according to the fault whichever occurred. For example, if there is any fault in catalytic converter, or if any fault in exhaust gas oxygen sensor, or even in crankshaft sensor, if the faults which will directly associate the emission level of the engine or the emission of the engine, then immediately that faults will be associated with the OBD, and accordingly that OBD will indicate the fault in the cluster. That is, or you can say instrument cluster or driver information system. So according to the fault, the driver has to take the vehicle to the service station, and once the vehicle has been taken into the service station, and there they will do the offboard diagnostic. There they will connect the scanning tool or the scanner and try to rectify the fault, or try to see what is the fault code is associated for that error, and accordingly they will make the changes required for the vehicle effective operations. So what to monitor in case of an engine issue, especially in terms of engine issue, the most of the fault is related towards the OBD. For example, if the problem in the ABS ECU or airbag ECU, that are all not comes in form of the OBD, that are all comes into the fact of what you called offboard diagnostic only. For example, what are the parameters which can be monitored? Since all the sensors, actuators, and similarly functions, whether the closed loop control is happening or not, whether the control function is effectively operating or not. So all these things related to the injection system. Similarly, these systems related to the air system, and mainly and most importantly, the exhaust gas treatment system like oxygen sensor, temperature sensor, particulate trap. Nowadays, the Euro 6 engines or the BS6 engines will start to use the selective catalytic reductions, SCR. So all these components will be continuously and rigorously monitored with the help of the diagnostic system of the engine ECU. And if there is any fault, there may be the fault, may be the sensor fault, or the sensor fault in the sense sometimes the sensor may give the signal, but the signal is not appropriate. Sometimes the sensor will not give the signal. So there are it will try to identify the faults, which type of the fault, or it will try to diagnose which kind of fault, and accordingly it will indicate those fault in the instrument cluster. But generally there is only 1 milliamp is associated with the OBD. So that will say just there is a problem in the engine. It won't say what is the problem. Whether the problem of EGO sensor is not working, or the problem of air temperature sensor is not working, or crankshaft sensor is not working. So it won't say what is the problem, but it will just indicate as the problem, just that milliamp will be glowing. And once if you will connect the diagnostic tool with the ECU, then only you can able to retrieve what is the problem in the vehicle. So that's what we will call as the onboard diagnostic. Is an automotive term referring to the vehicle's self-diagnosis and reporting capability. So it can able to diagnose its own, and it can able to report immediately for the indication to the driver. So OBD system gives the vehicle owner or a repair technician access to the status of the various vehicle subsystems, even vehicle subsystems also. So the amount of diagnostic information available via OBD has varied widely since its introduction from early 1980s version to the onboard nowadays. So there are two versions usually has been used in the OBD. That's what OBD1 and OBD2. Maybe we can discuss in the coming slide. So the earlier version of OBD would simply illuminate a malfunction indicator light if a problem was detected, but it won't provide any information as to the nature of the problem. Okay, what kind of problem? It won't say whether the problem is serious, or the problem is not that much serious, or whether because of that problem the vehicle function will be affected, or the fuel injection system function will be affected. It won't say such kind of things. But modern OBD implementations uses a standardized digital communication port to provide the real-time data in addition to the standardized series diagnostic trouble codes, or DTC. So nowadays, by means of using the what I call separate diagnostic tool or a diagnostic scanner, you can able to communicate through the OBD, that is the onboard diagnostic, and thereby you can able to retrieve the trouble code, that is a DTC, which allows a person to rapidly identify and remedy what kind of malfunction is within the vehicle. So this is what the difference between the OBD1 and OBD2, or you can say the OBD scanning versions versus OBD2. So the vehicles which is manufactured before 1995 or between 80 to 95 car models are comes with the OBD1 system, but whereas after the car whichever it is manufacturers are coming with the OBD2. So the interface is nothing but in case of manufacturer specified only from manufacturer to manufacturer you can't able to use the different scanners. But whereas in case of a OBD2, it is a universal. Any type of scanner can be integrated with any vehicle. And installation connects to console to bit quite easy to use. But this is again, it can able to work with the help of wireless, Bluetooth or Wi-Fi nowadays. Even mobile diagnostic scanner also available. So that are all certain advantages of the OBD2. And outcome generation, whereas in case of OBD1, gives the results after considering the energy and fuel consumption and comparing the results to the output. It will just compare the output of the how much of the energy and the fuel is consumed, and accordingly it will give the output. But here in case of OBD2, improved signaling protocols and messaging formats to provide the results by taking into account of different factors. Not only it will take the fuel and energy factor, but it will also take the other different operating factors also for providing the output. And comes to the popularity, of course, the OBD2 has a higher popularity than the OBD1. And of course, accuracy also will be very much higher in case of the OBD1, sorry, 2. And if you will come to the functions, so whatever the OBD1 function can able to do, all the things can be done by the OBD2. But the thing is that in case of OBD1, it will just check the whether the primary fault, like whether the circuit is open or closed, what is the some limited value of diagnostic only it can able to do. But whereas in case of the OBD2, where it can able to give the higher level sensor fault for each code, each fault will be associated with the code customization, performance level, like number of parameters has been introduced in the modern day OBD, that is the OBD2. And how the OBD is being integrated with the what you call vehicle system. Means, for example, here in the figure you can able to see this is a simple one ECU they have plotted. Okay, this may be engine ECU or it may be any other ECU, maybe a ABS ECU or any ECU. This ECU is connected towards the OBD interface. OBD interface is nothing but there is a particular what you called pin is connected. Maybe yes, you can able to see here. This is the OBD connector, which is present in the inside the vehicle. Otherwise, I can show you separately in detailed manner. Yes, you can able to see in the vehicle this OBD2 connector or OBD connector will be somewhere near the dashboard. So through the dashboard, the what you called the scanning tool can be connected. So like that, each and every ECU will be integrated with the either what you call J1850 standard or ISO 914 standard through the K line or CAN communication. Whatever the protocol they will you following, all the ECUs will be connected through the CAN, and the particular CAN will be connected towards the OBD interface. That OBD interface is a 16-pin connector, and through that 16-pin connector you can integrate the computer with the diagnostic software or the mobile phone also nowadays, or even the separate scanning tool. So the vehicle control units are equipped with the diagnostic protocols. That diagnostic protocols is nothing but it will store the fault code. For example, this is one ECU will store the one fault code. That fault code will be transferred to the CAN through the CAN or any one of the protocol wire, and that wire is connected towards the OBD interface. And once if you will connect the computer to this OBD what do you call that connector, you can able to retrieve that code, or you can able to see that code. And if that particular code is it has a separate data sheet code, this particular code is associated with the particular fault, and let mechanic will retrieve that code and understand that what is the exact issue. So accordingly, this OBD system can be what you called interface, and it will be interfaced with the ECU and the external computer. See, this ECU is present inside the vehicle. This may be through this OBD interface, any number of ECUs can be integrated or interfaced. And this ECU is whatever the fault which is stored inside the ECU can be retrieved and seen in the scanning tool. This scanning tool may be a computer or a separate tools also can be used. So the typical vehicle diagnostic feature checks the status of the functions performed by the subsystems, sensors, and other systems. components, and accordingly there is a, if there is any error, that error will generate according to a particular and for each and every error there is a particular diagnostic trouble code will be, or DTC code will be generated, and according to the DTC value we can able to trace the fault which is in the vehicle. See, this is what, see, this particular ISO connector or the OBD connector will be connected with a series of ECUs, number of ECUs through the either K line or a CAN communication or a J standard, whatever the standard will be available, and accordingly it will be connected towards this connector. And if you connect as external PC or laptop through the diagnostic interface, and you can able to retrieve the what you called code with the retrieve the what you called that particular diagnostic code. Either you can connect the PC or laptop, or separate scanning tool is also available. So what can be done with the diagnostic tester? So this is a typical diagnostic tester. So this is scanning tool or the PC or the laptop with the particular diagnostic software is nothing but as a, we call it as a diagnostic tester. So the diagnostic tester is an interface between personal or a laptop computer and the vehicle diagnostic bus, that is the OBD. So through the diagnostic, you can able to reprogram the controller to the certain extent. The hardware and software comprises a system which will read the most standard OBD data as well as the diagnostic trouble codes. So the codes related to the onboard emission related errors also, and as well as the other diagnostic trouble codes also can be read by the tester or the scanner. Provides the useful data for monitoring the real-time data, troubleshooting and repair purpose. So by means of this trouble code, you can able to what you call monitor the real-time data, you can troubleshoot, and as well as you can repair it. So, and accordingly you can able to manipulate the calibration data. That manipulation is in reprogramming of the controller or calibrating the data to the certain extent. So this is a typical what you call screenshot, or you can say the photograph of the scan tool. So this is a type of one scan tool, and this is another type of scan tool, and this is the what you call the visualized view of the scan tool software which is present in the software. So there may be three different types of scanning or diagnostic tool can be followed. One is a handheld scan tool like this or like this, and another one is a PC based or laptop based, and of course another one is a mobile device which may be a phone or a tablet related applications through which you can connect towards the OBD connector and you can able to retrieve the data. So next one is a diagnostic codes. That is a diagnostic trouble codes. That is it, as I told you, that DTC. A DTC code is a series of diagnostic trouble codes used by vehicles onboard diagnostic system to alert when a vehicle experiences a malfunctions. So different DTC codes represent specific problem in your vehicle. There will be a lakhs of diagnostic trouble codes will be there for in a vehicle. So for a particular ECU itself, there are thousands of diagnostic codes will be there. So they are how OBD2 in case of light duty vehicles are J1 1939 standard. See, as I told you, in light duty vehicles, the from connection between ECU to the diagnostic port, OBD port, either it will be happened with the help of CAN communication or with the help of J1939 standard communication. So that is the standard protocols they will be using, and through that the technicians can able to connect the what you call laptop or the scanning tool to identify the what fault for what fault is existing or happened. So DTC codes help you to understand what needs to be fixed, so you can able to keep your vehicle safe and healthy. So ultimately the state of health can be what you call analyzed or identified with the help of the particular diagnostic trouble code. So the way when the vehicle's OBD system detects a problem, it generates a specific DTC code and transmits the alert correspondingly to the vehicle's instrument panel as a warning light. So in a vehicle equipped with the telematic system, the alert can be delivered directly to the fleet. It is nothing but, for example, telematics is nothing but that is a one more issue where the group of vehicles can be monitored with the help of in the centralized system. For example, all the government buses can be monitored in the fleet. So if there is any fault in particular bus in the particular issue, that can be also transmitted through the telematic systems. So typically, what are the what you call responses which will be handled with the help of diagnostic codes, and what are the data? For example, it will give the request current powertrain diagnostic data, freeze frame data. Freeze frame data in the sense when the particular fault is happened. So at that instant time, what is the other sensors operations? What kind of input has been provided by the sensor? What kind of the actuators has been given to the sensor? So any particular conditions can be matched for the particular diagnostic trouble code time. So So that's what we'll call as a freeze frame data. So during the particular operating condition, if any fault is happened, that conditions will be freezed, that particular data. So request for emissions related diagnostic trouble codes, and once the trouble codes has been settled or sorted out, and it can be cleared, and it will give the onboard monitoring test results, and of course other vehicle related emissions apart from the engine related or emission related applications only. It will give the entire vehicle related applications also. So how to interpret a diagnostic trouble code? So how a diagnostic trouble code will be there? So basically a DTC code is a 5-character long. So it will consist of a 5-character length. You will almost familiar with this over time once if you will started to see those codes. So basically there are 4 different types of codes will be used generated. One is a P codes, C codes, B and U codes. P codes are related to the powertrain related errors, includes engine, transmission and associated accessories. If the C code is related to the chassis related ECUs, covers the mechanical systems like steering system, steering related ECUs, suspension, braking and all those things. And B codes are related to the body related errors found in the passenger compartment area. And another code is the U code, which is related to the network and vehicle integration functions managed by the onboard computer system. So whatever the errors which is happened related to the network issues, for example, CAN network or LIN network or whatever the network you're using. So those informations will be related towards the network related issues. And the second character will be consist of either usually 0 or 1. If 0 is coming, then it's a standardized SAE code, also known as generic code. And if it is a 1 value is coming, then it is a manufacturer. According to the vehicle to vehicle manufacturer code is there. So typically you can able to see this is a typical diagnostic trouble code P0301. So if this particular code is coming, for example, P code is related to the powertrain, 0 is related to the generic code, and 3 is related to the ignition system or misfire. So if accordingly this will be vary from 1 to 8. If 1 is coming, then fuel and air metering related error. If 2 is coming, fuel and air metering injector related malfunctions, like that. So if, and similarly final two digits are assigned towards a specific fault task. For example, here ignition system means in ignition system there are a lot of components are there. So that 0 and 1 related to the specific fault index. So there the vehicle manufacturer will give the list of fault codes, and accordingly if the 01 is related to the spark plug 1, if 02 means if it is related to the spark plug 2, or you can say the pin number 1, pin number 2, like that. So directly the technician can able to see this code by through the diagnostic scanner, and that code has to be compared with the available diagnostic code list, DTC list, and accordingly he will trace the fault and he will able to rectify the fault. And here another important aspect of the diagnostic system is the malfunction. So as I have already told you, a malfunction indicator light which will be appear in the vehicle instrument panel. Now if there is any fault in the system, maybe the engine ECU or any other ECU, to inform the driver about there is some fault in the vehicle. So typically a diagnostic system management inside the ECU. So here whatever the components which is here, this is all inside the ECU. What are the components inside in the behind this line? These are all the related to the inside the ECU. For example, there in each and every ECU there is a presence of DSM, that is called as a diagnostic system manager. So that will take all the sensor, actuator and the system related inputs and will continuously monitor with the help of the program stored in the memory. And if there is any problem, particular code will be generated and that code will be transmitted towards the CAN wire or whatever the communication through this onboard connector. And once you can able to connect this onboard connector towards the laptop or the any scanner, you can able to do the service in the service station, or directly you can send the vehicle towards the plant also, depending upon the fault. So this onboard it can able to diagnostic and give the fault in the vehicle running itself, and offboard it is a after service, or the vehicle is in the switch off conditions. So the functions of diagnostic system manager in an typical ECU is that it will store and as well as delete the errors, how to handle the errors. It is programmed in such a way that which error is of a high priority, which error is of a low priority. Also to handle the malfunction indicator lamps based on the errors. Stores the error relevant data. During the error is happened, what is the other vehicle operating conditions? It will freeze those operations in the read-only memory or random access memory and give this data to the external world through the diagnostic tester. So these are all the certain functions of the diagnostic system manager. So in each and every ECU, the diagnostic system module or the diagnostic system controller will be there. That is a diagnostic system manager. The DSM is programmed in 4 different ways, either model based control or a knowledge based control or a signal based control or a data based control. So in a model based control, a typical mathematical model will be developed according to the, and accordingly the physical process will be assigned, and which is used and depending upon the sensor inputs and outputs, it can able to what you call give the correct output. And knowledge based, it is again a prior knowledge, like for example in neural network based or fuzzy based, like that. And similarly signal based, if the signal based in the sense if there is a signal is weak or signal is lost, and accordingly it can able to give the value. And another one is a data. So here also a training of a black box by means of the neural network model is trained, and accordingly if the present data and the training data is varied, and accordingly it will able to give the output. So this is a typical diagnostic connector I have told you. So it consists of a 16 pin. So each and every pin has been assigned towards respective wires. So this is about SAE J standard wire and the CAN wires. So this all the pins will be connected towards the CAN wire of the all the ECUs. So the data link connector usually is the multiple pin diagnostic connection port for automobiles used to interface a scan tool with the control module of a given vehicle and access onboard diagnostic and as well as live data streams. So accordingly, for example, through this data link connector, there is a particular network will be there. That network will be connected towards the application layer of the all the ECUs. So all the ECUs will be connected towards the CAN, and that CAN will be connected towards this CAN or a SAE-J communication protocol. And once if you will connect towards the what I called laptop or a scanner with this tool, you can able to retrieve the particular fault or whatever the problem is associated with the particular code. For example, for each and every fault in the ECU in any particular ECU or in the vehicle, it has been programmed in such a way that there it will generate a particular code. So there are different types of codes will be there. There are lakhs of codes will be present inside the diagnostic system manager of the ECU. So those codes will be associated with a particular fault. So and if you can able to connect towards the scanning tool, and you can able to retrieve the diagnostic code, and you can see the code. The particular code is matched with the particular error, and you can directly go and trace the error, and you can able to service the particular component. So this is the overall working of a diagnostic system of the ECU which is present in the modern day vehicles. For further details, you can contact me, and my contact information is given over here. Thank you.